Hello everyone, welcome back to my YouTube channel. I hope you are doing good and having a fantastic day. This is the part 2 of basics of digital image processing. We know that in the part 1 I covered the topics like what is an image, what is a pixel and image resolution, and also discussed the importance of bit depth in digital image processing. Next we have seen the difference among the color image, grayscale image, and binary image. So if I've not gone through the part one, my sincere request is that please go through the part one first and come back to the part two because it is a continuation to the part one. So now we'll see the what are the content I'm going to cover in this video. So first of all, we'll see the what is mean by image segmentation. Then we'll see the application of image segmentation in agriculture. Next, we'll see the different image segmentation methods. Next, threshold-based image segmentation. Next, we'll see the image thresholding via grayscale and RGB channels, case studies. So we'll go to the first slide now. So what is minimum image segmentation? So I will give you the one small definition for the image segmentation. Image segmentation is the process of dividing an image into meaningful region or parts so that each region specify the something specific. It may be the background, it may be the foreground, it may be the region of interest. Okay, this is the definition for the image segmentation. Now we'll see one example here. So you can see in this image, there are fruits and plant leaves are there. Okay. If I use any image segmentation model, it has to divide the image into parts or regions as per the definition. Now we can see here. So fruits are there, fruit segmented separately. It is a special region. Leaves are there and background. Okay. So this is a labeling. So first one is the orange fruit related that. Next two are the leaves. So this is the main goal of the image segmentation. We'll see second image. You can see in this image, road is there, plant trees are there, and mountains and sky. So if I use any image segmentation, it has to divide the image into regions. Okay, as per the definition, you can see here. So road, it has done fantastic job. Road, trees, next mountains and sky. Now you can see labels: sky, mountain, tree is the tree, and vegetation, road. Okay. So now you can see that image segmentation has done a fantastic job on this both the images. Okay. Okay, Upender. We got to know about image segmentation, but what is the application of image segmentation in agriculture? Where I can use? So now we'll see the applications as well. So you can see here. So you can the first image plant or crop segmentation. Here also we can use image segmentation models. You can next thing is a weed detection. Next leaf disease detection. Next thing is that fruit or vegetation detection. Here also we can use image segmentation model. Next canopy or vegetation cover estimation. Next field area measurement. Next, paddy crop segmentation and plant counting and yield estimation. These are all the cases we can use image segmentation model. These are only few are collected from the internet, but there are many applications are there. Okay. So if your curiosity to learn, please go and search application image segmentation agriculture. You'll get plenty of case studies. Okay. Plenty of research papers. So, okay. Now we will see the different image segmentation methods. Okay. We got to know about the definition of image segmentation and we have saw the application of image segmentation in agriculture. But what are the different methods are there that I want to highlight here now? So what is the role of the image segmentation? First, we have the original image. So with the image segmentation, we'll get the binary mask. Next, we'll get a segmented RGB image. Okay, so again, say a second image, same. This is a tomato. So we segmented RGB image. Next is a green. I mean, you can consider as a weed or plant, whatever may be. So we have to segment it. Okay, we'll get the binary mask. Then we'll get the segmented RGB image. So how will achieve the binary mask from the original image? So you can see. So there are different techniques are there, methods are there. I'm highlighting few here. One is a threshold based approach. Next is edge based detection, edge based segmentation method. Edge detection based. Next is clustering based and a deep learning based. Clustering is generally we know that k-means clustering. So that is most commonly used unsupervised machine learning algorithm that is used for the foreground and background separation. So there's different techniques are there. So they are helpful for they are helpful and useful for the image segmentation task. Okay, Upender, with help of these methods, we'll get the binary mask from the original image. What about the segmented RGB image? How will get this? So in order to get the segmented image from the binary mask, or from the original image, we don't use any specific techniques or algorithms for this. Just we use the one bitwise AND operator. Okay. So with help of bitwise AND operator, we'll get the segmented RGB image from the original image and binary mask. Okay. Now we'll go to the next slide. So in this video, I'm mainly focusing upon the threshold-based image segmentation. Okay, I have discussed many, different segmentation methods, but in this video, I'm entirely focusing on the threshold-based image segmentation. First, we'll see the threshold-based image segmentation. Okay, Upender, we got to know image segmentation and different image segmentation method. So we are talking about threshold-based image segmentation. But what do you mean by thresholding? So again, I will give you one small definition for the thresholding. Thresholding is a process of converting an image, it may be RGB image or it may be grayscale image, into binary mask by comparing the each pixel intensity values with the predefined threshold value. That is meaning of thresholding. Okay, thresholding is a process of converting an image may be the grayscale or color image into binary mask, but by comparing the each pixel value with the predefined threshold value. That is the definition for the thresholding. Okay. Okay. Now we will see the with the type of figure, we'll understand that. Okay. You just take an original image, any image. Just I'm taking bead here in a soil background. So next, what is the step? I need to have a thresholding. I need to apply threshold value on this image. So I said that we compare the each pixel intensity values of the original image with the predefined threshold value. Okay, and we define a threshold value. We'll compare with that, and after comparing that, we'll get the this binary image. After that, from the binary image and with the help of the original image, we'll get the segmented RGB image. Okay, don't worry. These are steps we generally follow in case of in case of threshold based image segmentation. Now we'll see the thresholding via grayscale image. So you know that in the part one we are discussed about the what is meant by grayscale image, color image, and binary image or binary mask. So grayscale image is a single channel image. Please understand that. Okay. So for RGB image will be there. We try to convert into grayscale image. So in the grayscale image, we'll try to apply the threshold. So you know that the threshold value ranges between 0 to 255. Why? Because grayscale image is a 8-bit image. So pixel values ranges from 0 to 255. So the value could be any value between the 0 to 255. Even sometimes it could be range. Maybe pixel value between greater than 80 and less than 150 also could be the threshold value. Okay. Like that also we can select. So like this is the way we'll get the binary image. So after applying threshold value, we'll get the binary image. Now we'll see the thresholding via RGB channels. So as I said in the previous slide, we are seeing the single channel, we are going to apply the threshold. We are applying the thresholding on that. But in case of RGB, we try to apply the threshold on three channels. We can apply the threshold on red, green, and blue. At least one channel also we can use. If you want to use three channels, also we can use two channels, also we can use. Okay, any channel we can use. If you want to use the three channels, we need to optimize the three threshold values. Please understand that. Okay. Next, we need to apply threshold value. We'll get the binary mask like this. Please understand one observation here. As I said in the previous, in the part one, if we capture any image that is a green or red or blue, so in case of in this image having green object, so green channel intensity will be higher. I told you that higher means brighter object. You see, because the object looks green, so green pixel regions having brighter as compared to the red and blue channel. Please understand that if this object looks red color, so the plant pixel that is belongs to the this region, so will be brighter in the red channel as compared to the green and blue. Please understand that if this image contain the blue, that means the blue channel, the related to that object will be brighter than the green and red. Please understand that. So another important thing is that so we have a different color models. Now it is RGB color model, HSV color model, YCRCB color model, lab color model, XYZ color models also available. So even you can apply the threshold on those color models also. Okay, na? So my intention of here is telling RGB channel means we can apply the threshold on any color model. This in the Python we have only one line of Python code. We can convert the RGB into HSV. We can convert the RGB into lab color model. We can convert the RGB into YCRCB also. Okay, in any color model we can use for the image thresholding. Please understand that. Now we will see the how thresholding works internally. Okay, Upender, you mentioned the definition and everything, but how it's happened internally. So how can we convert the original image into binary mask? Now we will see this. So you can see for this example, I'm not taking three channels. I'm taking only single channel. It may be red channel, green channel, blue, or you can take any. grayscale image. So here this image is width is 4 pixels, height is 5 pixels. So each pixel having the pixel intensity. Okay. Because you know that the grayscale image will have the pixel intensity values 0 to 255, ranges 0 to 255, that you know that. So you can see this first pixel coordinates is 0 comma 0, this is 1 comma 0, this is 2 comma 0, 3 comma 0. Okay, what about this one? This x coordinates 0, y coordinates 1, so 0 comma 1, like this. So you can see the particular pixel intensity value 120. As I said that we compare the each pixel intensity values with the predefined threshold value. So here here pixel intensity value is 120, we need to try to compare with the one threshold value. So what is this? You can see this condition. So I'm just, for this example, for this demo, I'm taking threshold value as a 120. So if 120 is greater than equal to 120, then that pixel should become 255, else 0. So you can see this condition will satisfy because 120 greater than equal to 120. So this pixel will become 255. So what about 125? 120 is greater than equal to 120. So this also become 255. Same thing here also. But when you come to the 50, 50 greater than equal to 120, because 50 is less than equal to less than 120, so this becomes 0. So like this we'll get the this binary mask. Okay, in case of thresholding, like this it works internally. Actually we'll use a for loop here. I will show you with when we are discussing with the Python code. I will clearly tell this, but you understand this logic. Okay, this is the way we get the binary mask from the original image. So I think you got the point. Now we will see the how we'll get the segmented RGB image from the binary mask. So you can see this for this example. I mean, we need to have a binary, we need to have a original image and a binary mask. Both the things we need in order to get the segmented RGB image. Now you can see I have taken the original image. So one pixel I'm taking here. The pixel coordinates are 220 into 503, 503. So pixel coordinates. What is the pixel index values? Red is 220, green is 120, and blue is 30. Okay. So next again I need a binary mask. So same pixel I'm taking here. So 250, 255, because it's a white, the entire fruit region is white. So it will, the pixel index value is 255. So one thing we need to understand is that, so the bitwise AND operator, we don't use directly on these values, decimal values. We need to convert into binary values. So you no need to convert anything. There is a Python code, single is a Python code. It will do internally everything. So we need to just understand it. No need to remember anything. So it will do internally. So because for 30, so binary value is this one. For 120 binary value this one. Like this, we get the all the binary values. So we can do the truth table for AND gate. Okay. So 0, is 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. When the two highest values are there, then only it will be the output will be the one. Please understand this. Okay. AND gate. Now 220, first we'll compare with the red with this one. Next to blue, sorry, green with this value, and blue with this value. Okay. First 220, you can take 220, this value. So this is the 255, 255 value 111. So you can see, so you can tell me. So 1 1 high, so 1 will get. Again 1 will get. So 0 1, so 0 only. So 1 1 1, 1 1 1, 1 1 1, 0 1 0, 0 1 0. So we'll get the, again same red channel will get. I'm right. Again red channel will get it. So 220. Same thing. Green also same. You take green binary values, then compare with the 255, we'll get the again green channel. Next blue channel same. So like this, you can see this when you're comparing with the, when you use the AND gate between the those fruit pixel region versus the binary, this mask region, white portion, we are getting the exact fruit pixels only. Please understand as output. Now we will see the background pixel also. So you can see I'm taking the background. So you same pixel I'm taking here 250 into 503. So all background pixels are white. So it will be 255, 255. R is 255, G is 255, blue also 255. So here you can say black color, so it will be 0. So decimal values and binary values, you can see this. So now you can see same again. I'm comparing same R versus 0, G versus 0. Okay, blue versus 0. So 255. Next, AND operator we are using 0 0. So output is 0. You can see 1 0 0 1 0 0. So again we'll get the 0 only. So these background only will get as output. Please see. So even it can also green also same. It can also blue also, it is same. So please understand this. Okay. In the previous slide, when comparing fruit region with this mask, we are getting the this pixel intensity as the output. But in this slide, when you compare the background with this black, we are getting the black, darker. So you can see here original image, binary mask, then we use the and will get the this region. So entire fruit region will be extracted. The background will be black darker. So this is the way we'll get the okay segmented RGB image. I think you got the full clarity on this. How we'll get the binary mask from the original image and how to get the segmented RGB image from the binary mask. Next, we'll see some case studies. How to do that? Okay, we'll understand cases so that we'll understand more deep into this. So, case to target spraying. Okay, even my PhD topics on target spraying, site-specific herbicide application. In this, just understand that this is my PhD image only. So, total pixels are 640 to 480. You can understand as you treat it as a weed. So with the help of a thresholding operation, we can remove the background and we can extract the this weed pixels region. So you see in this entire image, we have the 640 into 480 pixels are there. So in white pixel region, nothing but a weed. Please understand that white pixel region is the weed. So just these total pixels are 25,000. Just assume that this image, these white pixel regions are 25,000. Now, so you know that by comparing these two images, we'll get the segment RGB image. I'm not going to use it anywhere. Just understand that we'll get this one. So weed coverage percentage. How to calculate? So white pixels, we know that total pixels, we know that 640, 480, then we can calculate it. We can calculate the weed coverage percentage. So with help of this one, we can go on to activate the solenoid valve. So you can activate solenoid valve or you can also activate the proportional control valve. So we know that in agriculture, we want to stop the application of band spraying. We want to move to the target spraying. So with the help of this image processing and some hardware, like with the help of a solenoid valve, we can go for the site sensor application. So you can see this, we can put the one logic here. If weed coverage percent is greater than 5, we can spray or else no spray. Okay. Even we can go for the proportional control valve. With the help of proportional control valve, we can control the quantity of herbicide to be applied. With the help of duty cycle, pulse width modulation, we can control the quantity of herbicide to be applied. So that is also we can do that. So this is a one case study. We can do that. Next is the fruit maturity estimation. You can see here, just assume that on the belt conveyor, fruits are moving. Here I'm taking an example as a papaya. So image resolution 1280 into 720. We know that 1280 means width of the image, 720 is the height of the image. So you can apply the threshold here. So after applying the threshold, we'll get the image like this. So entire background has been removed. So white pixels, binary mask, we'll get this segmented RGB image also. We'll get that. You know that, okay? How we'll get this segmented RGB image? You know that. So fruit region pixels. So I'm calculating the fruit region pixels here. So 2 lakhs 7,000 200 pixels. I assume that. So again, okay, Upender, I got the fruit region. Next, I want to get the only ripening region. I want to do that. Again, we need to apply the segmentation. I mean, thresholding on this segmented RGB. You see, in the previous case, I have not used that segment RGB image of weed. So in this case, I'm using this for again. I want to use this image because this segmented RGB image will have the color feature, texture feature. This is the original feature only. Original fruit, how it looks, it also looks in the segment RGB image, so that we can use it for the further analysis. But in case of binary mask, it does not have any color information. It has only shape. We can, by using this one, we can percentage of fruit pixels, how many we can calculate from this image, and we can shape related features also we can extract from this binary mask. But with the help of segment RGB images, we can use this image for the color analysis. Also, we can use texture feature. Also, we can extract using the segment RGB images. Please understand that. So again, I will apply the threshold on this. I will try to extract the ripening region. So you can see this again in this image. I extract the fruit ripening portion. Okay, like this in segment RGB, you can see this. So fruit ripen region pixels and 1 lakh 2,200 pixels. Okay, just I calculated that, we got it. So now we can calculate the what we can call fruit ripening percentage. We can calculate this. So we can see here fruit ripen region pixels. Okay, divided by fruit region pixels. So this is a fruit ripen region pixels divided by the this entire fruit region pixels. Okay, then we'll get the ripening percentage. Okay, you see, we are not using this as in the denominator because this image contain the belt conveyor and background everything. We want only fruit region. So please understand, sometimes we will try to keep this one. No, we should not use this one. We need to use this fruit region only. Out of this entire fruit region, what is the percentage of ripening? So So you must use the fruit region pixel. First, we need to extract the fruit region, and then after extracting the fruit region, we can apply the threshold, and we can get the this ripening pixels region. So this is the way we can calculate that. Next, if the fruit ripening percent is greater than some 60 or 70%, we can tell that it's a ripened fruit or else unripe fruit. So like this also we can do that. Next, we'll come to the fruit grading purpose. Maybe in this same belt conveyor, I'm using the citrus fruit orange. So again, we can apply the image segmentation, and we can extract the fruit region binary mask and segment RGB images. Next, on this binary mask, we can calculate the features like size, area. Also, we can measure perimeter, diameter. We can extract. Okay. After calculating this one, you can go for the fruit grading also. Next, you can calculate the shape features also. Not only if you think that in the belt conveyor different types of fruits are going, maybe papaya is going, orange is going, banana. So different fruits are going. In that case, we can calculate the shape features, circularity, aspect ratio, solidity. If you can calculate it. After calculating the circularity, aspect ratio, and solidity, we can go for the fruit classification also. So that is the useful of image segmentation. Please understand that. Okay. Next position, centroid bounding box. Maybe on the belt conveyor, fruits are moving and maybe you want to count them. So we can draw the bounding box on each image and we can go for the counting. Even robotic harvesting also, like in the tree, maybe you can capture the images. I mean, you can capture the tree images with fruits, and with help of this image segmentation, we can locate the fruit location, and robotic arm can go there and pick up, plug it. So like that also we can use image segmentation. Please understand, these are some of few of the case studies I want to highlight in this video. So see in the next video also I will try to cover a few examples. So we'll come to the end of the slide. I mean, end of the previous video. So just a quick recap. So what is meant by thresholding? Thresholding converts a grayscale or color image into binary mask using a threshold value. So thresholding separates the object from the background by comparing each pixel intensity with the threshold value. So what is image segmentation? Image segmentation divides an image into meaningful regions or objects. Next, binary mask. So enable the quantitative analysis such as the area measurement, object counting, disease severity estimation, and canopy coverage calculation. Next thing is segmented RGB image. It enables the color, texture, and quality analysis for applications such as a fruit maturity estimation, fruit grading, disease classification, and seed quality inspection. Okay, this is please write down somewhere else. Try to read at least by heart so that if anyone asks you that, so you can easily answer these questions. Okay, I think thank you so much for watching this video. So we will meet in the second video. Till then, bye bye. Take care.